Okay, so if we're looking at problems from section 10.2, let's start off by looking at number 6. Okay, so on number 6 here, we start taking a look at, they give us some information about 40 eruptions of the Old Faithful geyser in Yellowstone National Park. The duration times are recorded along with the heights in feet of the eruptions. The paired duration, time, and then heights, so we're comparing time and heights in here as a match pair. They were obtained the results showing the accompanying Excel document. Is there sufficient evidence to support the claim? So we want the claim in which there is a linear correlation. So I'm going to go linear correlation between the two. Okay, so are we showing that there's some to where as time goes up, the heights go up also, as time goes down, the heights go down. So we want to see if there's something, or if the times are short, the heights are high, and then as the times lengthen out, then the heights go there. So either as one goes longer, it's going up or down. So they don't tell us if it's positive or negative. So basically what we start talking about is we start talking about our hypothesis testing of being equal to 0 or not equal to 0, because we don't know what type of correlation we're referencing. So they ran this test and they got an R value of 0.091548. So now we need to know how to compare this to what's going on. So on your guys' folders, let me find where it's at here. So on our folder right here, we have this lovely table A6, talks about critical values of the Pearson correlation coefficient R. So we're going to come down here and we're going to go to n equals 40. Once again, not knowing what's going on, we're going to use alpha equals to 0.05, so 95% confidence. So we see that we get a critical value of, n is 40, 0.312. So we see that our critical value R equals, I'm going to go plus or minus 0.312. Okay. Now the reason why I did plus or minus is, once again, if we start talking about a positive correlation or a negative correlation, we could have the positive part or that negative part, depending upon what's going on with the correlation itself. So as we see here, we see that this value, our test value for R, is smaller than our value. So it's not in our critical region. So we fail to reject our null hypothesis. So remember, if we fail to reject this null hypothesis, this is saying that there is no linear correlation. So basically what we state now is there is not sufficient evidence, sufficient evidence to support the claim that there is linear correlation between time and height of Old Faithful. And once again, we could clean this up and write a little more specific to what we're talking about. And that's what we should be doing as we're writing this, but I don't want to drag this out longer than it has to be for you guys. Jumping over to number 8. Okay. So on number 8 over here, they talk about serial killers. Okay. So the amounts of sugar and calories were recorded in a sample of 16 different cereals. So it tricks you with the serial killers. We're talking about actual cereal and how the sugar in cereal can kill you. So they gave us a couple information here. They talked about we have 16 cereals. We're comparing the sugars to calories, which this isn't vitally important for what we're talking about. They give us an R value, so they ran a linear regression t-test, and they found an R value of 0.654, so on and so forth. What we want to do now is we want to compare this to our critical value. So if we come back here, and we find 16. We see 16 right here has a 0.9, or I'm sorry, 0.497. So our critical value is 0.497. So as we look at this, we see that this R value is above. Now once again, I can do that plus or minus here for a positive or negative. So we see that we are in the critical region. So because we are in the critical region, that means we fail to reject. Okay, so remember our null hypothesis, rho equals 0. Our alternative hypothesis does not equal 0. So this would be here, we reject the null, because once again this value is higher than this, so it's a critical value. It's higher than our critical, so it's in our critical area. So we reject this null hypothesis. Now remember, this alternative hypothesis was showing that we have linear correlation. So we can now come and state that we're going to support the claim that there is linear correlation. So there is evidence to support the claim of linear correlation, once again filling out all the values that go into this. Okay, continuing on, we're going to look at number 14. Okay, so on number 14 here we talk about the PSAT and the SAT. So it basically talks about a list of individuals where they took the PSAT test scores and then the SAT test scores from prospective college applicants. The scores were reported by subjects who responded to the request posted by the website talk.collegefidential.com. If there is sufficient evidence to conclude that there is linear correlation between this, is there anything about the data that might make this questionable? Okay, so once again, we're testing, is there sufficient evidence to conclude that there is linear correlation? So our claim, there is linear correlation between our SAT and our PSAT. And really this one is our X, this one is our Y. Because as we're looking at this, you would take your PSAT test before your SAT, so this would be the input. Is it leading us towards what this output would be in value right here? So if we were to look at our null hypothesis, once again we'd be talking about it equaling 0, where there would be no linear correlation, and then our alternative hypothesis in this case does not equal 0, okay? Because we're just talking about linear correlation. We're not talking about a positive linear correlation or a negative linear correlation. If I were doing this test, I'd probably test more towards a positive linear correlation. Once again, that this is showing signs that a higher score here is going to give you a higher score here. But the way the book is, we're testing towards a linear correlation. Now, what we would want to do is we would want to come to our calculators here now. Once in our calculators, we would go into a new document. I'm not going to go into the new document because I spent the time and typed in my information here. Once we're in here, let's see if I can angle this some. You see we would have a spreadsheet. I would title PSAT and then SAT on this. As we would look at that information, please make sure as you're typing it in, you are matching it up. So if I arrow back up here, we see that the 183 goes to the 2200. So PSAT test score of 183 leads to 2200 on the SAT from that same individual. We have the 207 and then the 2040, so on and so forth. Once we have this information, what we would do is we would come and we would hit our home button and we could come down and we would bring in a calculator function in here. Once we bring in our calculator function, we're going to use our statistics, stat tests, in which then now we're going to come down here to a choice, and notice it says linear regression t-test. Okay, so we've clicked that linear regression t-test, and now it's going to ask for our x list and our y list. So if I go to my x list, that's going to be my PSAT. My y list is going to be that SAT. They ask for where to put information, frequencies, not there. Notice here at the bottom is our null and alternative hypothesis. So once again, the alternative hypothesis does not equal 0 in this case. So we would have our other options in here. Notice if we had greater than 0 or less than 0 for our positive or negative regressions in here. Once we hit OK, we get a whole bunch of information. So they give us all this information in here. We get a t-value, we get our p-value, okay? So depends upon what we're going into and what we're going to be looking at, we can start concluding in here. So I'm just going to come here and list off some pieces of information. My p-value is 0.164. If I keep going down, there is an R value. My R value equals 0.543. Okay, so these are some pieces of information that are good to important. Depends upon what type of test we're doing. Notice we're not doing a confidence test, so I don't know precisely what I'm using here, but we would think 0.05, in which then we see that this is larger than 0.05, so we're not in this critical area. The other way is we would come to our table, recognizing that we had 1, 2, 3, 4, 5, 6, 7, 8 scores in here. So if I went to 8, see that under a 0.05, I have 0.707. Okay, so I could go like this. Critical value would be 0.707, or I could go alpha equals 0.05. Either way, we see this is not smaller, this is not larger, so we're not in that critical area that it would be. Once again, the p-value tells us the area, so our area here is greater than what a 95% confidence would be. Under this one, our value is not larger, so we're not past what this critical value would be. So in this case, we fail to reject our null hypothesis. Because we fail to reject the null hypothesis, that means that now we're not siding with the claim. So basically, there is, excuse me, so there is not sufficient evidence to support the claim that there is a linear correlation between your PSAT test score and your SAT test score. Okay, so basically we showed that there's not evidence here to support any claim of a linear correlation. So taking that PSAT test and getting a high score there does not deem that you're going to have a high score on that SAT test. Once again, we start talking about, is there anything about the data that might be questionable? Well, number one, let's bring out the red marker. Number one, it was a volunteer survey. Okay, volunteers don't necessarily give us good pieces of information or that are very reliable, but sometimes they do work. The next thing we start talking about is a simple fact that we could possibly have different tests, different styles, better days. Maybe you studied more, you didn't take the PSAT test seriously, and then they took the SAT test seriously. So there's so much piece of information in here that we could look at. We could look at Serious. You know, were you serious on one and not on the other? Maybe you did better on the PSAT because you took that serious, and then your SAT you just blew off because you decided you didn't want to go to college. There's so many different things that could go into this. We would have to look at other types of correlation. Okay, do realize this just tested linear correlation. Okay, so is there any other correlation going on right here? We don't know that either, so there still could be much correlation going into this, but it's all depending upon what's going on. So basically, this is kind of what goes into this linear regression test in here. Do remember it is a hypothesis test, but unlike in the past, we generally always have this as being not linear correlation. This is our linear correlation. Once again, if this is positive linear correlation, we would go p is greater than 0. If it's negative linear correlation, we would go then less than 0. So do realize that this isn't always just not equal. It depends upon what we want to test up here, if it's just straight linear correlation or if we want a positive or a negative linear correlation. That's going to affect this test a little bit in here. But once again, it's relating to our values. Okay, so we have a p-value, we get an r-value. We could either use a critical value here, or if we use our alpha, once again, if we know what type of test we're referencing.